Hello and welcome to this video. This is actually a follow-on video from the two videos that I had for tutorials on creating a threaded hex nut and bolt based on Too Tall Toby's tutorial using Onshape. And in Alibre, it seems that not every version or level of Alibre is going to have design configurations that I illustrated in my last video creating the hex nut. So in this one I'm going to kind of step back away from using configurations, but I'm still using design Boolean features to create the threads in the hex nut for the appropriate clearances that I have here. What this requires though is that instead of having design configurations in one part model, in this case in the bolt, it requires having two files, two bolts that you can use, one in your assembly and one for the Boolean feature. And these two parts need to be matched up as far as the threads are concerned. Now this one, if you look back, go back and watch the other videos, I had configurations for thread normal and thread parallel, and then I had the threads at scale and with surfaces offset. So there was like 4 configurations. What I've got here is a model that has the threads with the helix at the normal, and thread set to normal in the helical thread profile. And what I'll do is I'll create a hex nut in here, and then in that hex nut I'll create the Boolean using a version of this hex bolt set to threads normal, but with the threads scaled to give us the clearance. So let me go ahead and get started. I'll create an offset, actually insert a part here. So I'll go to insert part, insert new part, and then I'm going to create a sketch or a plane on this. So I'll offset this 25, and then in this plane I'll create a sketch. So the steps here are going to be the same as what I did on the in the previous video, so I'll just kind of brush through it fairly quick. I'll grab a project, grab this face, and then we'll get rid of this inner circle here, get rid of that, and sketch in a couple of circles here. We got an 18 millimeter hole in there, and then we've got the reference circle here that is tangent to the outer hex, and then we're going to extrude that mid plane to 20 millimeters. Okay, so next I'll hide the bolt, and then I can do a chamfer of 5 millimeters on that hole, and then I'm going to trim up the corners, get a couple of lines here, go vertical, horizontal, and then come back with a tangent arc from this line down to the bottom of that vertical line, and then we'll do some constraints. But before I do that, I'm going to project a sketch, the create reference and maintain association. So now I've got my reference geometry sketch projected here. Do a vertical, and then we'll get some collinear. And then this arc. Ooh, what's going on here? If you have a constraint that's stuck on something, you can hold on your control key, select the arc and move it off to the side. See what happens here. There we go. All right, now we're looking better. And we're at 2.5 here. And I'll just revolve cut that off the y-axis, and then mirror that to the bottom of the hex nut, and we're done. Okay, now we can unhide the bolt, edit the root assembly. We're back in our assembly, and we'll go ahead and file save this, and bolt nut assembly, and I'll call this version 2. And the hex nut V2, and I must have another one in there, V2 already. I'll just overwrite that, and we'll okay this and overwrite. Okay, so now I've got my hex nut here, and I'll open this, edit this in a separate window, and get my windows adjusted here. So now I need to create my Boolean here. But looking back in my assembly, my bolt is a normal thread profile on the helical setting. So I need to use a Boolean that matches this normal thread orientation or setting, and I also need it to be adjusted to give me clearance. So let me go to my, and I've already got some copies here. So if I'm looking for my thread normal, and I've got a thread bolt assembly, thread normal, here's normal and scale. So I've got this normal thread, but I'm scaled it to enlarge the thread. Click one time, and then we'll show reference geometry, and then we're going to constrain this the same as the part in the assembly. Now mind you, these are two separate part files. So they're only related in name only. They're not, it's not the same file. So any changes you make in one, you'll have to make in the other to maintain the thread pitch and settings. So the only thing I've left my scale normal, I'll just name the configuration thread normal scale. So now my thread is scaled to be enlarged, and I'll accept that Boolean. And now I've got my thread cut in there, and I'll close this window to go back to my assembly. And now if I go to inspection tab, activate my XY, turn off my toggle off my planes. Now I've cut my Boolean in there with the clearance already preset in that part. Now note, that is not the part that I use for Boolean, is not the part I have in my assembly. The only relation they have is that the thread, or the helix, has the same setting as far as parallel or normal on the advanced tab. So you could do the same thing if you're going to use a parallel thread. Then you need to have two files for parallel, and in that one, rather than using scale, it was an offset face on there. So whichever way you determine to make your adjust or create your sizing for clearance, just make sure you have two files that work together to give you the proper clearances, and you don't end up jamming threads. So anyway, I hope this little addendum to the thread making video helps out, and if there's any questions, just leave your comments and I'll try to get back to you. Thanks for watching.